All right, so today we're going to start concept 3, where we are still factoring trinomials, but this time I'm not going to split up the terms for you. I want you to see how and why we split up the terms. Okay, so let's take a look at some examples. The first thing you want to remember is that no matter what it looks like, no matter what you're doing or what method you're doing, the first thing you're always going to do when you're factoring is look for a GCF. So looking at our 3 examples, let's look first for that. Here I have 6, 42, and 60. Well, I know 6 can go into 42 and it can go into 60, so at the very least I can pull out a 6. So yes, this has a GCF, and you'll see that it's out here out front. I'm going to highlight that, and you'll see why later. We're going to need that greatest common factor in our final answer, and it's easy to forget about. So anytime you factor out a greatest common factor, please highlight it so that you remember it's there. Next, we have 5, 9, and 2. Well, I can't factor any number out of all 3 of those, and I have n squared, n, no n, so I can't factor out any variables either. So no GCF here, and you'll see that it's just rewritten as it originally was because we didn't factor anything out. Then here I have -5, positive 19, and 4. Well, technically there's no number that goes into 5, 19, and 4, but remember we said that if your first term is negative, you have to factor out a negative. You have to. That's the rule. You've got to do it. It won't work if you don't do it. So because there's a negative here, yes, there is a greatest common factor. We're going to take that -1 and factor it out. Okay, because we can't factor out a 2 or a 3 or a 5 or anything like that. So we're just going to take out a 1, factor a 1 out. The coefficients will still stay the same. The constant we moved over. But what you'll notice is that the signs changed. Instead of -5r squared, now we have a positive 5r squared. Instead of positive 19r, now we have a negative 19r. Okay? So when you factor out that -1, just divide by -1 the same way that you always would to see what's left over. So once you have that done, you've factored out your greatest common factor, the next thing we're going to do is we're going to split that middle term. And we're going to do that using an x. What I want you to see about this x is that at the top there's a times and at the bottom there's a plus. Here's how this works. We need 2 numbers because remember we're going to take the middle term, we're going to split it up into 2 separate numbers. But what numbers do we use? Well, they have to add up to this middle term, so they have to add up to positive 7. So how can we add up to positive 7? Like it could be 1 and 6, it could be 5 and 2, it could be 3 and 4, lots of ways we could add up to positive 7. But then it also needs to multiply to something. What is it going to multiply to? We're going to take our first coefficient, which in this case is 1, and our constant, which is 10, and we're going to bring these both up here, and we're going to multiply them. So 1 times 10 is positive 10, because a positive times a positive is a positive. So I need 2 numbers that will multiply together to get 10, but add together to get 7. Well, how do I figure that out? I'm going to take this top number, the number that we need to multiply to, and I'm going to factor it. So if I factor 10, I could have 1 and 10, I could have 2 and 5, and then 5 and 2. It starts to repeat, so I'm going to stop there. If I take 2 and 5, I can make 7 with that. If I have a positive 2 and a positive 5, well, a positive times a positive is a positive, so that's good. 2 times 5 is 10. That works. Plus 2 and plus 5, or positive 2 and positive 5, gives me plus 7 when I add them together. So these are my 2 magic numbers, 2 and 5. And what I'm going to do with that is I'm going to take this equation, I'm going to rewrite it as x squared. Instead of this positive 7x, I'm going to split it up. And I'm going to make it plus 2x plus 5x. Notice that that still equals 7. 2 and 5 still equals 7, so I haven't changed anything. I just split it up. Okay, and now I have 1 group and 2 groups, and now I can go ahead and factor each group looking for my twins, which we did in concept 2. So here I can factor out an x, and I'm left with x plus 2. Here I can factor out a 5, and I'm left with x plus 2. Notice that my twins are here, which is awesome because that means I can factor them out. Goodbye. Goodbye. And what's left over? X plus 5. So now the factored form of this equation is going to have x plus 2 times x plus 5. But remember, we had that greatest common factor. Always, 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 when you're writing your final answer, double check to make sure that if you had a greatest common factor, you're including it again. So we're going to bring that right out front. So 6 times x plus 2 times x plus 5 is the factored form of this original equation up here. Let's take a look at another one. Here we didn't have a greatest common factor, so we need to add up together to positive 9, and we're going to take this one, and let's see, positive times a negative is a negative, 5 times 2 is 10. So I need to multiply to negative 10 and add to 9. So, let me factor out my 10 here. I've got 1 and 10, 2 and 5. Well, I can make 9 if I have 1 and 10. If I have, let's see, I want it to be a positive 9. So I need my big number to be positive and my little number to be negative. If I use a negative 1 and a positive 10, they will multiply together to be negative 10, and when I combine them, I will get positive 9. So these are my two magic numbers. So I'm going to rewrite this now as 5n squared minus 1n plus 10n minus 2. So I took my middle term and I just split it up into two separate terms. The reason I did that is so that I would have group 1 and group 2. And now I can factor just as I normally would. Let's see here, I can factor out a 2. And if I divide by 2 in both spots, then I get 5n minus 1. Awesome, my twins match. So I'm going to factor them out. 5n minus 1, factored out. Goodbye, goodbye. And what's left over? N and positive 2. So the factored form of my original polynomial is 5n minus 1 times n plus 2. And I don't have a greatest common factor, so I don't need to pull anything down. I'm done. So let's take a look at another example together. I need two numbers that will combine together to give me negative 19, and that will multiply together to give me, let's see, 5 times 4 is 20, and I have a positive times a negative is negative. So I need it to multiply to negative 20, combine to negative 19. Well, I know that if I factor 20, if I use 1 and 20, I can make 19 with 1 and 20 if, let's see, I want it to be a negative. So my big number is going to be negative, my small number is going to be positive. So when I multiply together positive 1 and negative 20, I get negative 20. Good. When I combine them, I get negative 19. So now I'm going to take this and I'm going to rewrite this middle term as plus 1 and negative 20. Watch. 5r squared plus 1r minus 20r minus 4. So all I did was rewrote this middle term. I split it up. My first term and my last term stayed exactly the same. But now, ta-da, I have two groups. So if I factor out, let's see, 5 and 1, can't really factor anything out of both of those. R squared and r, I can factor out an r, and I'm left with 5r plus 1. Here, my first term is negative, so I have to factor out a negative. And let's see, 20 and 4. Can I factor a 4 out of 20? I sure can. So I'm going to factor that out, and that leaves me with, let's see, go ahead and write my division here so I don't mix up my signs or anything. Negative divided by negative is positive. 20 divided by 4 is 5. And the r is not being canceled, so it stays. Negative divided by negative is positive. 4 divided by 4 is 1. So there we go. And I check to see, do my twins match? They sure do. So 5r plus 1 gets factored out. And what's left over? Well, r and negative 4, r minus 4. So my factored form is 5r plus 1 times r minus 4. Check for a greatest common factor, and there is one. So we're going to pull that out front and just write it on there so it's being multiplied all together. So your final form will have your two binomials, and it will have your greatest common factor. All right? So that concludes part 1. Check out part 2 if you'd like to see some more examples.